Good morning, it's lovely to be here. I actually was in Stockholm last week for our large summit event, and I guess there might be a few people that were here at that. This is a little bit more of a technical talk. I'm going to be talking a little bit about patterns in use cases for serverless architectures. But before I do that, I'd just like to know who here is using AWS Lambda or has built something using Lambda today. Okay, a minority of people. So this should be pretty interesting, definitely for the rest of you. I'm going to talk about a few detailed use cases for Lambda, which should also contain a little bit of content that's interesting for the guys that have used the service before. My name's Ian, as I've been introduced. I run the evangelism function for AWS in Europe, Middle East, and Africa. And I was going to do something today that I've never done before, which is include a slide which causes everybody to groan in the audience. But before I did that, I thought I would just say at the beginning of the session, I'm hiring evangelists for the developer relations team at AWS in Stockholm and Berlin. So if anybody here would like to talk to me about that after the session, I'll get my plug-in first today instead of at the end. Okay, so you can find me on Twitter here and stay up to date with AWS service announcements on this account as well as our main accounts, of course. So what is Lambda? Well, Lambda is actually the third in a triplet of AWS services that developers are using to build large-scale applications without servers. Now, of course, there are servers involved in this, okay? There's no magic. It's just that we provide a set of abstraction layers that allow you to work directly with service endpoints to deliver functionality in your apps without having to provision any servers. So you have nothing to manage, no operating systems, no containers, and no infrastructure. You just work with our service endpoints. We provide the opportunity for you to execute code and also to persist data and objects in a couple of different services that we provide. Probably you're more familiar with S3. It's been around over 10 years. DynamoDB, it's got a 4-year history as a non-relational database with consistent and very good access performance, also very durable in nature. And then Lambda is a little bit newer. That's actually been around for a couple of years now. We announced it at reInvent in 2014. And it's seen really good adoption. And it's really that adoption that I want to talk about for the rest of the session today. Now, all of these services have some simple characteristics in common, simple to access, they're very scalable. In fact, as developers, you have nothing to scale. You might have to ask us to raise a few service limits, but really there's practically unlimited amounts of capacity here, and I'll talk about that a little bit later when I come to one of the example use cases that I've got. They're very reliable, so we obviously manage the underlying infrastructure. We abstract that away from you, and we just provision the amount of capacity that you need as you need it. And they offer low latency, which means they can be used for interactive apps, web and other applications that are more interactive in nature. Focusing on Lambda itself for a second, what is, I think, most interesting about this service is the way in which the metering works. So you're essentially billed for the memory footprint that you use in 128 megabyte increments over time chunks of 100 milliseconds. Okay, and there's a very, very small, very sub-cent charge for each chunk of that capacity that you use. We also provide a pretty generous free tier on this service, so you can invoke 1 million Lambda functions and consume 400,000 invocations and consume 1 million seconds of execution time per month forever with this service. So it's not a free tier that runs out. You can just consume that baseline amount of capacity for as long as you want. And I'll give an example later of a customer that's built a web application using this service, and the costs are incredibly low for the amount of traffic that they drive. And one of the reasons for that is the majority of their app runs in this free tier component. They only use a small amount of incremental capacity on top of that. So how are customers using this service today? And really one of the predominant patterns is use of Lambda to power the back end of serverless web applications. And this can be at any scale. I hope you'll also notice that there's a really broad range of different customer types that are using this service today. One of the most interesting ones is this organization called Logalytics. Localytics rather. And this is amazing. The numbers involved with this are pretty phenomenal. So we kind of think about this as normal today, but I just want to remind people that these numbers are not that normal. They have 2.7 billion mobile endpoints connected to this application, and they have 37,000 mobile apps that are registered. And they use Lambda to gather and aggregate usage statistics in applications that mobile developers have chosen to deploy through a couple of different app stores. So you're talking about being able to support usage numbers like that. It was just unheard of that you would build apps that big even 5 years ago. But today, with the cloud at the back, there's the opportunity for elasticity in the platform that can support that. And I wanted to spend a bit of time talking about one specific example of a serverless web application that is built on Lambda. Not this one. This is another example from the US, but this one. So probably everybody here has heard of David Guetta. He's a French DJ, and he's working in partnership with UEFA, the European governing body for football, obviously, to produce a track, so a record, for the Euro 2016 championships this summer, okay? And they decided they wanted to make this a mass participation event. And what he's done is got 1 million individuals to record their voices singing along to a track that he's created, okay? So there's a web app that's been produced, actually by these guys. This is a digital agency from the UK called Parallax. Quite a small company, and they act as a digital fulfillment agency to the prime agency that have the digital marketing contract with UEFA, with Chelsea, and with a few other big football clubs, okay? And what Parallax have built is a single-page web app that looks a little bit like this when you load it. So has streaming video in the background. You can scroll down the page, and there are a number of different functions here. Each one of these functions is expressed as a RESTful API endpoint, and the entire application is delivered in a completely serverless manner. So there are no EC2 instances, there are no relational databases. In fact, there are no persistent service components at all at the back end, apart from DynamoDB and objects that are stored inside S3. And the flow for the application looks like this. So there's a page lifecycle that's established when you load the app. The first thing that happens is you obviously download that initial HTML and JavaScript asset. That comes directly out of S3 with the CloudFront distribution in front of it. They then assess the language of the browser that's been used to pull down that first asset, and they reload a new copy of the page, which is localized, okay? They have support for 5 or 6 different European languages: Turkish, Chinese, Japanese, and Korean. Okay, so you can see that they've got a global audience for this app, and this talks to some of the scaling factors that we're going to talk about later. Users can then insert their details, so you're recording your name and also which club you support, and that data is going to get used a little bit later on for something else, but it's persisted immediately inside DynamoDB via another Lambda function which sits behind an API gateway. Okay? And after that, you move down the page a little bit. You can optionally link the session to Facebook. You then grab the video asset, which is David Guetta explaining what you're going to do. So he talks a little bit about the track, and he plays back the audio track together with some of the voices doing the singing, and encourages the people that are visiting the application to record their own voice. Now, I tried to do this demo live at another audience like this, and I discovered one thing, which is that software developers do not like singing in public. So I won't be turning around my laptop and asking you to do it, okay? But I did try it before, and it didn't work out that well. So what happens is the people that are using the app, mostly, I guess, in the privacy of their own home, where they're not going to be too embarrassed about singing, then do the audio recording. That's captured as an MP3 file by a browser-side component. It's pushed to S3, and at this point, a social media image is generated. So they create this, okay, which is built using a Lambda function that composites together an image that the application's grabbed off Facebook, normally a profile pic. It overwrites that album artwork on top of that image, and it then makes that available for you for sharing. They use an external social sharing endpoint, which you can see here, which allows that image to be shared on the user's social networks. And then they store some details about the user at the end so that they can later on draw a competition prize for everybody that's participated in the event. Okay, so that's the app. Built entirely without any compute capacity. Everything is a browser-side component or a collection of services that are running on various AWS endpoints. Okay, so some metrics. They could have built it like this. Okay, so this would be a traditional N-tier model. And there are some obvious disadvantages with that. The main disadvantage with it is, in any kind of public campaign like this, you're working with forecasts, right? you've got a set of anticipated usage data that comes from the customer. In this case, their customer would be UEFA. And UEFA gave them some numbers about how big they anticipated traffic volumes to be. But of course, with a campaign, you've got a ramp. You start off with provisioning and testing, then you'll start to get substantial usage on the service. But you've got to build out this infrastructure at day one to cater for that usage peak, right? That's the normal deployment model. They calculated that this would cost them around about $12,000 a month in AWS service charges to build, okay? Because they had to build it to scale with this peak volume that they're anticipating in month 2 of the campaign. They built this, which looks more complex, but actually the vast majority of what you can see on here are service endpoints. You've got your Lambda functions here, and we're illustrating the different API resources that are being made available via this API gateway. We've got our static assets and our social media images that are being stored in S3. We've got transactional email confirmations going out with our email service SES, and then we've got our persistent data for those subscribers being held back in DynamoDB. So there's nothing running there in terms of EC2 capacity or, in fact, any services that have to be scaled beyond their actual usage level. So if option 1 is $12,000 a month, does anyone want to have a guess at what option 2 is in terms of the initial ramp up? So say month 1 of usage. $9.30. Okay, so that's about 1,000 times cheaper than option 1. And then, of course, they started to get really busy, you know, as more and more people started to come onto the campaign. And actually, the French FA decided that they would put the application on a train and run that train around France with a physical recording studio on it, still using the same app and back end, but taking this to different cities, parking it in stations, and getting people to come onto the train and record their own voices, which is a kind of quirky little real-world aspect of the campaign. So they started to get really busy, and when they got really busy, it cost them $173 a month, okay, for the same output as they would have got with this $12,000 infrastructure stack over here. So it just completely breaks the connection between infrastructure resilience costs, where you would have to buy 2 of everything, distribute that across AZs, and also breaks the connection between volumes. As Adrian said, you can scale up as big as you want, but you can scale down to 0. When you scale down to 0, your cost will also be 0 for the variable component. There's a small amount of data that's persisted in Dynamo, and there's a small amount of data that's in S3, but those aren't material costs because it's a relatively short-term campaign. Okay, on testing, by the way, when you start with Lambda, it's worth noting out that you have a 100 concurrent function limit in your AWS account. So if you want to lift that, you have to ask us. Just do that via our limit increase process that we have. A lot of you will have used it already if you're using EC2 in any significant volume. They tested to 5,000 concurrents using a load generation tool that they'd developed, and they were very able to deal with that. And the counterintuitive thing about Lambda is the more volume you have, the more frequently you spin up the functions, the faster the functions perform. So actually loading and continuously running the same function over and over again means that it gets cached on our infrastructure, and the spool up time for initiating new copies of that function will be substantially lower than a cold start. You're talking about maybe 250 milliseconds to cold start a function, whereas if you have that function cast on the infrastructure, it's practically instantaneous to launch it and start sending traffic. So that's a little bit on web apps. Another common usage pattern that we see is serverless data processing, and there can be quite a lot of different ways in which this is implemented. A very common one would be something like image or video transcoding, where you want to have on-demand actions to transcode images that might be uploaded as part of an app, or you want to do something with video. And with video, there's some really interesting techniques emerging. The guys at Parallax have been experimenting with concurrent frame rendering. So you want to build a piece of customized 3D rendered video. They've actually got a parallelization model where they have one Lambda function rendering each frame. So they'll spawn 25 functions for each second of video that they want to create, render each one of those frames, and then composite those back into an MP4 for playout. Okay? And they've tried rendering in real time, where they'll have a small run-in, maybe 5 or 6 seconds of pre-rendered video. In the background, as that starts to play in the browser, they then custom render the custom components of the video that might have the individual social media image in it, so it's personalized. By the time the 4 or 5 seconds of pre-render have played out, the 6 or 7 seconds of custom render are ready to go, They just stream that into the browser. It looks like one seamless video experience to the user, but part of it is concurrently rendered using Lambda functions in the back end. This particular use case here is about intrusion detection. So they're using Lambda for parallel processing of security events. A little bit like re-implementing something like EMR or Hadoop inside Lambda functions, but they're processing events in parallel, operating logic on those events, and then obviously in the case of this intrusion detection service, they're doing things like triggering alerts on the basis of what they find in security events. Again, it's all done using parallel Lambda functions at the back end. Okay, who knows what this is? Ever use one? Has anyone ever used the Alexa Skills Kit, which is the extension system for this, where you can write your own voice-enabled apps? Well, that's interesting. Normally in the room this size, I'd find at least a couple of people that have experimented with that. So we describe this as a voice-activated speaker, and you can basically talk to a service endpoint by using this device. You could say, you know, Alexa, play me some rock music, and it would be connected to a music service and would start to stream audio out of the device. You can order stuff on Amazon with it, predictably. You can add stuff to shopping lists. With the right back-end technology integrated with it, you can also do other things. Capital One in the US, they've got an application that allows you to check your credit card balance and your minimum payment by talking to a speaker in your house. What they do at the back end is integrate the Alexa service with Capital One's public API, using your account credentials to read data out of your account and voice transcribe that and speak it back to you. That's quite a new service, and there's quite a few auto manufacturers in the US that have got applications as well that they've built using this. And, well, you're probably saying, why is this relevant to Lambda? Well, every thing that Echo does, every extension that's been developed for it is actually a Lambda function at the back end. Okay, so what we provide with the service is something called the Alexa Skills Kit, which is the development environment for people that want to build voice-enabled apps. When you talk to the speaker, we have the voice-to-speech engine. We transcribe whatever you say to them, whatever you say to the devices. We pack that up inside a JSON object and we send it to a Lambda function that you've specified, effectively routing it on the basis of the first couple of things that you say. We have natural language detection for a lot of services, but also you can extend it by doing things like Alexa, tell Nest to increase the temperature. And the fact that you've used that tell Nest prefixed would indicate which skill you wish to use to process that next block, route it into a Lambda function, execute whatever logic you want there, and take third-party actions or return voice back to you to be spoken to you via the speaker. I'd encourage you all to take a look at this. It's really easy to get started with, and despite the fact that the device is not available here in Europe yet, we do have a lot of developers here that are working on the platform, particularly in Germany and the UK, where we've done some hackathons with this device. It's pretty popular. So who'd be interested in that, by the way? If we came to Stockholm and did something on voice-enabled, would there be any interest in that? Okay, cool. Maybe we'll try and set that up. That would be good to do, I think. And obviously behind that, we've got other IoT services as well. This is something that I wanted to just talk about and then do a quick demo with to show you how easy it is to get started with Lambda functions and also to change and modify them. So this is our IoT platform. I don't know how many of you are familiar with this. We launched it last year at reInvent 2015. And we've got a portfolio of components here that connected device application developers can use to build services on. And we have a lot of people that are using this today. Big ones here in Europe would be people like Veolia, the water network operator in France. They're building network management and fault detection services using AWS IoT at the back end to do that. The components are quite interesting. So we've got a device-side SDK, which is JavaScript and C SDKs that sit out on the devices that you're building, and I'll show you one in a second on this camera that I've got here. We've got a mutual TLS auth system using X509 certificates and public-private key infrastructure to make sure that you can secure connectivity to and from the devices. It can be really important in things like health informatics and safety-critical systems where you don't want to have anything unauthorized communicating with your device, and you obviously don't want eavesdropping on what could potentially be private data. This gateway, which supports this protocol called MQTT, which is a lightweight transport protocol for reducing the power footprint of lightweight devices that you want to connect to endpoints. It's about 170 times more power efficient than HTTP because there's no key generation. The keys are pre-shared, and that really reduces the amount of power that it needs. Then we've got this rules engine. This essentially reads the contents of messages that are coming off your device fleet and can perform routing logic on those messages on the basis of their content. So messages coming with certain parameters inside them could be sent to different endpoints. And then this shadow, and this is a mechanism for allowing developers to work with devices that might have intermittent connectivity. One of the best examples of this actually is quite near to here in Norway. They have Telenor Connect. They're an IoT business unit of the state operator there. They connect sheep to the internet, okay? And they do biometric monitoring on the sheep. Really, they're looking for ill health in their livestock so that they can maintain the health of their herd. I was going to say fleet then, their herd, and make sure that those animals have got good well-being and are also productive in terms of producing whatever the product is that the farmer's producing. And with these sort of radio networks that are literally out in the field, they can be very kind of difficult to work with. You've got topological features like valleys and trees that get in the way of the radio signal using low-power radio, so you can't kind of drive it over a wide area. And this shadow allows you to work with devices that aren't actually connected. You can read and write state from a virtual representation of the device in the cloud, and then when that device is available again, our client-side SDK will perform a synchronization action, and either push device state out or refresh the state in the shadow once connectivity is re-established. That's also a pretty important feature. Okay, so next is this. I'm going to show you something here. Okay. Okay, so this is this. Okay, I don't know if anybody's seen one of these. This is a AWS. We call them a reInvent button, an IoT button, but they've got some commonality in terms of the form factor with another Amazon device, which is called a Dash. Okay, now if you've been in the US, you might have seen one of these Dashes. What we do with the Dash version of this device, it's a Prime product that Prime subscribers in the US can get. We manufacture them in conjunction with FMCG manufacturers, so like Tide washing powder or Gillette razors or nappy manufacturers will have one of these devices with their branding on it. When you press the button on the device with the appropriate branding, it will basically buy that product from Amazon. Okay, and then they'll ship it out to your house. And we have a mechanism to prevent repeat ordering where you can't actually register another order for the product until you've taken delivery of the prior delivery. Okay, so it's a way for FMCG providers to kind of position something physical in the homes of their customers and hopefully get them to be a little bit more loyal. What we see with the washing powder one is the people stick it on the front of their washing machine and it's right there when they need to buy more, they can just press the button. It's pretty cool. This one's a little bit different, okay? What's inside there is a AAA battery, which gives enough battery lifetime for this button to be pressed 1,000 times, and also a Broadcom ARM chip, a Wi-Fi radio, and a tiny amount of solid-state storage. On there, we have our C SDK and an X509 certificate and a private key. Okay, and that endpoint will communicate with our IoT service, so can actually initiate Lambda functions by pressing that button. Okay, and I'll show you how that works in setup on the back end. So in our IoT console, you can see here, we've got a few different entities here. This is the button itself, so the representation of that thing inside the service platform. This is a certificate which is installed on the button, and it has a public-private key pair associated with it. The public key for the certificate that's on the button is installed on our gateway so that we can encrypt our outbound traffic to this button. And on the button, there's a corresponding public key, which we hold the private key for on our gateway. So we've got this mutual TLS authentication and encryption. Then we have a policy that allows this particular entity to work with one of our API endpoints. And then we have a rule. It's worth digging into the rule. So The rule corresponds to that rules engine that I showed you on the platform architecture a second ago. And you can see that when this button is pressed, a couple of actions will take place. One of them is an SNS action, which for debugging will deliver the payload of the event coming off the button into an email address that I've set up to capture that. And the second one is a Lambda action. And you can see that this particular Lambda action triggers this IoT button function. And if I jump into Lambda in the same region, you'll see that I have a couple of functions here. One of them is called IoT button function. And you can see the event source for that is configured to be that button rule. So that's where it's expecting to receive its trigger event and payload from. And there's also some monitoring here, and you can see that I've already activated this particular function once earlier today in testing. And I have a little example of the function code, which is here. So this is what's actually inside this Lambda function. This particular function is written in Python, as you can see here. We're importing some stuff which should give a clue as to what this particular function's concerned with, which is using the Twitter API. I have a set of secrets that I drag in from another module. And then I have a status being constructed here and posted to a Twitter API that uses those API credentials that I provided there. And if I jump into my Twitter account, so the frame rate on the camera is not great, but you can see that that button is flashing there. It went white, and then it went blue, and then it went green. And that indicates that it's been successful. And if we take a look at my Twitter account now, I'll just reload that. You'll see that I've got a new post there which says test post on it. And that corresponds to the status to post which is being built here. Okay, so that's been driven out by that function. I'm going to switch around these two lines, comment out the test post, and post something that's a little bit more enriched. So I'm going to drag in some data out of the event payload, the serial number for the button which is sent across, and also just note the time, and also this click type variable, which again comes off the button. So it'll differentiate between one press, a double click, and a long press, and it will deliver that in the payload. So it's multifunction. You can use it for a few different things. I'll save out that. And I've got a small script here which is used for deployment. So I just repacked the function and the modules that are associated with it into a zip file. And then I used the AWS CLI command to overwrite the pre-existing function using its ARN with the new package that I've just built there, and deployed it effectively into live. And if I hit that again, you'll see that the button begins to flash again. It's changed color to green. And if we take another look at Twitter, behaves or do a new release without having to push new code through an app store. Well, if all of the functionality in the app is delivered in the back end using a set of loosely coupled endpoints with Lambda behind them, you can independently rev that without having to push any new releases down onto any devices that you might be supporting. Okay, so that's a very quick demo of AWS Lambda in action together with our IoT service. Okay. So I'm going to close up now because I'm out of time. I'm being shown a count at the back telling me that I need to get off stage. So the other way that we see this getting used is as an integration or automation extension tool for other AWS services. And this is super interesting. So we've created event triggers for Lambda which come from other AWS services. Obviously, we've got DynamoDB streams, we've got S3, so that you can trigger functions on the basis of data, but you can also trigger functions on the basis of other events. There's a couple of really interesting things here. Capital One, they built a compliance tool called Cloud Custodian. It uses these CloudWatch events. Essentially, every time you make a change inside your AWS account, you can trigger one of these events. And with this open source project that Capital One have built, they evaluate what you've changed, establish whether you've gone outside configuration guidelines that they're specifying in order to maintain compliance, and then they'll remediate any issues that you might have created automatically using logic in the functions. So that's pretty cool. And with config rules, we do something similar natively where we trigger events on the basis of resource changes. So you might have modified a security group or created a new IAM user, for example. Again, you can trigger custom Lambda functions on the basis of those events, and you can auto-remediate those. And again, there's another repo on GitHub under the AWS Labs user on GitHub, which contains community-contributed rules where AWS customers have basically extended their compliance monitoring and contributed back the functions that they've developed to do that. So we also see this pattern for using AWS Lambda to extend the automation capabilities of the platform, particularly in compliance, which is quite interesting for me. It indicates that we're sort of getting off a security footing which is mostly manual and getting onto a security footing which is mostly system-driven, where it's all about implementing and enforcing rules rather than auditing. So with that kind of construct, it's possible to move much more quickly whilst at the same time making sure that you're operating in a compliant environment. And I think that is all I have. Thank you.
Good. Thank you. So we have a few questions. So question one, when should a serverless architecture not be used?
It's a good question. So I wouldn't say when should a serverless architecture not be used, because I think it's a potential fit for most application types. There are some restrictions with Lambda, like, for example, the fact that a function can't persist for more than 5 minutes. So if you're doing something that requires longer-term processing and a longer-term maintenance of state, you might combine Lambda with other services. One pattern that we've seen is using containers, maybe on our ECS service, our container service, or maybe on other container management systems, and triggering the instantiation of those containers using Lambda. So you kind of recognize that you've got a long-running job. You can still trigger it with an event, but the execution of that job doesn't happen inside the function, because the function is time-bound. So you're triggering other resources as you need to deal with these longer-term runtimes.
Okay. Good. So how do you make sure that your Lambda code works before you deploy it to the cloud?
Yep, so we have integration with CloudWatch logs, so you can see debug data from your code that's running natively inside AWS Lambda. We also support aliases and versioning for functions, so you can have multiple versions of a function, some of which might be public and some of which might be in testing. And there's a blue-green deployment model for functions there where you can quickly flip over from one version to another. And there are also a couple of community-contributed projects that will allow you to emulate and simulate and run Lambda functions locally on your development environment as well. So you've got quite a few different options.
Okay. Good. Cool. Thank you.
Thank you.